Good morning to all you Twins fans who checked in to see what your morning calculus looks like. Everybody, we have a small group today, so I think disease is rampant. Good morning, Noah. Are you happy with the Golden Gophers?
They won.
Yeah, they won. That's what I'm saying. You got to be happy. That doesn't happen all the time either. Why? Because it's in Minnesota. Alrighty. Let's say on the next quiz I give you this problem. And I ask you this. Do you have any idea how you would do that? See, the difficulty of teaching calc is there's two parts to calc. One part is the mechanical side, where you learn how to do particular things. Okay, and the other side is kind of the creative, insightful things. So here you have some tools. How do you solve a problem with those tools, especially one you haven't seen before? And I'm going to give you a hint. You have all the tools. You may know nothing about the product quotient rule or higher order derivatives, but you should be able to do that problem just with the tools that you have to your ability already. You would like notes. Who else just came in here would like notes? I think, do you have notes over there? Does Allison have notes onto hers? Yeah, you're set. Because people care about you, Allison. I wasn't going to put them there, but people say, we love Allison, we love Noah, we love Musab. Put the stuff there. Okay. Anybody have a clue? Yeah. Okay, what do you mean by factor? Okay, so that's kind of the reverse. Multiply it out, right? Or sometimes FOIL. Yeah, factoring is kind of a division thing, but no, I know what you mean, right? That's highly insightful. That's what I was looking for. So you would get this. You would change this, and I don't want to put words in your mouth, Natalie, but would it be this x squared plus 18x x plus 81?
Yeah.
Okay? And now you would get what if you took the derivative?
2x plus 18.
Would people agree? Okay, and that would be the right one. And Adam, we see why there is no 81, correct? Okay. So what if I would give you this? And so what I'm doing is I believe that everybody learns stuff about math. Some of it is correct and some of it is incorrect. And I'll get to a point in a bit. All right? What about something like this? And I asked you to figure that out. Now that Natalie has led the way, what do you suppose you should do? Okay, multiply it out, right? And so you get x squared plus 7x plus 12. And, oops, that's what f would be. Now the derivative would be 2x plus 7. Okay, everybody agree with that? All right, so what happens is we're going to learn something called the product rule first. And there is a tendency to do this. If you have two things you're multiplying by, let me call this h rather than f. And it's two functions being multiplied by each other, f of x and g of x. Like this would be one function and this would be another function. Does everybody understand that? Do you see that they're two linear functions? They both have the slope of 1. This one crosses the y-axis at 3 and this crosses the y-axis at 4, correct? And you're multiplying them. And when you multiply those, they become quadratic. That's what their product becomes. Well, what people want to do, and I'm going to write the next step is wrong. Okay, but this is how people do this. They say, well, it'd be really easy if it was this. I take the derivative of both of them and multiply. It seems reasonable. But what's happening, Allison? There's a door where it says, voodooist, welcome. And when you do this, you start to pull open that door. You're not a true voodooist because you're not proficient in calculus, though you are proficient in algebra, or theoretically supposed to be. But you've picked up some voodooism, some parasite that's running through your system, a few of you. This is the parasite trying to embed itself into your skin like a tick. I'll show you why it's wrong. You would be saying, notice how you said you would be? That's Wabash County. You would be saying, well, what's the derivative of x plus 3? 1. Times, what's the derivative of x plus 4? 1. And 1 times 1 is 1. You have just proven that x squared plus 7x plus 12 is equivalent to 1. And if I put 0 in there, you can prove that 12 equals 1. And if I put 1 in there, you can prove that 20 is equal to 1, and so on and so on. In fact, you can prove that 1 is equal to a lot of numbers. Do you see how you go down that road and become a full-time voodooist and believe that stuff? Hence, we need to have a different rule. We have a product rule. And what I'm going to do here is I'm going to do these three to show the application of the product rule, and then I'm going to come back and do its proof. Everybody okay on that? So the product rule of this one right here, let's say that f does equal x plus 3 times x plus 4. Rather than, I'm going to put a bridge here and make sure I write wrong, because I don't want people to say, hey, that's how you showed me on the notes. Okay? What the product rule says, the way you take this derivative is you write the first one down and you multiply by this derivative, which happens to be 1. And then you write the plus sign. It'll always be a plus sign. You take the derivative of the first one, which is 1, and you write the second one down, x plus 4. And now you combine, and you get x plus 3 plus x plus 4, and you get 2x plus 7. You get the same derivative as you would here. Now, Austin is saying, well, I would multiply those out every single time, just take the derivative. It's easier, isn't it? And I would agree. So anytime you get these, unless it specifically says you have to do the product rule or the quotient rule, the rule I want Austin to do is the one that's the easiest that gives him the correct answer. Does everybody understand that? The one that is the easiest and not the correct answer. Not the one that you learned last. Does everybody make sense? So, let's take a look at this. Yes, on this one you could multiply them out, like Natalie said, and take the derivative and have the correct answer. And there would be nothing wrong with it. But what I'm going to do is I'm going to model the product rule. Which of the rules we're going to do this week I think is the easiest. I like it. But there are some people out there that really, really, really like the quotient rule. And then you got people like Mrs. Benson and Ms. Sperskala that love the chain rule. I don't get that either. Okay. So anyway, I'm a product rule person. Okay. So here I'm going to have g prime of x. And you can see this okay? And I'm going to write down 2x squared plus 3x. I'm going to write that one down times the derivative of this one. Adam, what is it? 4 plus. What's the derivative of this one, Adam? The first one. 4 plus. So I got to put parentheses around it because that whole thing is the derivative. Does everybody understand that? That whole thing is. Times 4x minus 5. I've already taken the derivative of 4x minus 5, or Adam did. He said it's over here. So here's the first function times the derivative of the second plus the derivative of the second times the first. The derivative of the first times the second. So now I just go through and do my math, and I have 8x squared plus 3x plus 16x squared minus, I believe I get a negative 20x here and a positive 12x here. People agree? I get a negative 8x. Did I make a mistake? Is it a negative 8x? Minus 15. Does that look correct? Okay, so my final answer, my derivative formula is 24x squared minus 5x minus 15. Natalie, you got a question?
Wait, where's the 8x?
Okay, I multiplied these two, got 16x squared, right?
Yep.
The outer is a minus 20x. The inner is a plus 12x. 3 times 4, okay. Negative 20 plus 12 is a negative 8.
Negative 20 plus 12?
Yeah.
Negative, yeah.
Okay, I made a mistake here. People are seeing it. Good. Negative 15. Okay, so where did I make my... Oh, this should be a 12 here. I bet you I said 12 too. I bet you. So this should be a plus 4x. Thank you. Now, this is not the equation of the tangent line. Does everybody understand that? One, this is not a line. This is a parabola. The derivative function is some sort of parabola. The purpose of this is if I knew the x value of a point and plugged it in here, I would know the slope of the tangent at that point. Like if it was 1, I would plug in 1 here and have 24 plus 4 minus 15. I'd have a slope, I think it's 28, 13. Everybody understand that? It computes the slope for us. This one right here. H prime equals, I'm going to take x squared times the derivative of cosine. Nick, do you think you got an idea what the derivative of cosine is? It is a negative sign, and it tripped off your tongue very quickly. That's quite impressive. Plus, now it's the derivative of x squared. What's the derivative of x squared, Madeline? 2x times the derivative of sine, correct? Oops, derivative of cosine, sorry. That's my mistake. So my final answer would be, I put the negative sign out front because it's a coefficient. And you can leave it like that. You don't have to factor anything, you can just leave it like that. Questions? Everything okay? Over here. Oh, let's back up. Let's talk about this. That means 2 times cosine, correct? Did you need to know the product rule to be able to take the derivative of that? Ethan, you're saying no. You would say the derivative of 2 cosine x would be? Be negative 2 sine x. When this thing that you're multiplying by is a constant, you don't do the product rule. Some people do, Ethan. I'll show you got a negative 2 sine of x, didn't you? This is what people will do. They'll do this. They'll take, let's say they call it, they'll write down the derivative. They'll say, okay, it's 2 times negative sine x plus 0 times cosine x. Ethan, where did they get the 0? Yeah, they took the derivative of 2 and wrote 0. And they can do that, okay? And then 0 times cosine is what, Ethan? 0. And then when you add 0 to negative 2 sine of x, you get exactly what you said in 3 seconds. And now it's probably taken me 3 minutes, right? So if this is a constant, you don't have to do the product rule. Allison, is this a constant? 3x. No, we have to do the product rule here. So we're going to say that f prime of x is equal to 3x times the derivative of sine. What is that, Allison? Cosine. You were even gone. Very good. And then you're going to write plus, what's the derivative of 3x? 3 sine of x. And Ethan already said we're going to have minus 2 sine of x. Isn't that right, Ethan? Didn't you say that before? And so this one I can simplify and say my derivative is equal to 3x cosine x. 3 sine of x, take away 2 sine of x gives me 1 sine of x, correct? Right? Is everybody okay with that? I see one person nod, so that's usually a good sign. Usab, okay? So we're done here, right? One thing before we get to the proof. Suppose my question is this. Find the point of a horizontal tangent. And the reason I'm throwing this in here is because I know it's a question on your homework, because I picked it. Line. So you see the words tangent line, it means you're going to take the derivative, correct? Bingo, we did, Austin. We took the derivative. Correct? Now, what does horizontal tangent mean?
Zero.
Yeah, the slope is 0. So I got to make this thing 0. How do you solve that? I go to the machine. So I turn on my machine. You guys want me to do as a TI or right on the Casio? I go to menu, I go to my graph. I hit delete. I make sure I'm graphing something here, and I'm going to graph 3x cosine x, and I know I'm in radians because that's the only thing I do, plus sine x. And I'm going to create a window, and I always go from a negative pi, or negative 2 pi, excuse me. Where's pi on this machine? Right here. To 2 pi. And I'm going to go from negative 5 to 5. Let's just see what that looks like. Okay, exit, draw. It's wild, isn't it? Right? And I'm looking for where those are 0, correct? Right? So you need to know how to figure out where the x-intercepts are. Okay? If you're a Casio person, you will go to Shift G solve, which is an F5, and it should say root. Is that correct for Casio people? So if you press root, it'll give you the first answer, which is a negative 4.781. And then you press the right arrow if you're a Casio person, and it'll say a negative 7.5, negative 1.758. And then I press 1, I get 0, and I get that, and I get that. Okay? Everybody got that? If you're a TI person, you gotta do a little bit more work. I'm going to tape it in here again. Can you see that? Oh, you can't see it at all. Yeah, see that turns on. Can you see that? There, that's better, isn't it? See that? Oh, it can't. Man. Let's see if I lighten it up. Did that help or not? What's worse or not? Can you see it or not? Noah, can I get you to turn off the lights and see if that helps? They're up here.
Try turning the light on here.
Oh, bad. Turn on the light.
Turn the lights on your
Oh, leave it like that. It's perfect. Good job, Noah. You're amazing. All right. What did I have? 3x cosine of x plus sine of x I better make sure I'm in radians. Yeah, there I am. So what you have to do is go second calc, and you have something that's called a zero. And so I'm going to use my left arrow here. And you got to do a little bit more work. You do not want to use the trace button because it's going to be wrong. Oops. Here it is. You got to be to a little bit, you have to border the point. So you got to be to the left of it, and then you got to go by to get to the right of it. And then it asks you to guess, and then you press enter, and it thinks for a long time and gives you the same answer. Does everybody understand that? And then that's what I have to do. The advantage of the Casio, you just press, 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 and you get all of them. Okay, everybody cool on that? No calculator today? Do you have a calculator? I would get it out right now because I'm going to show you something really important. So I'm going to come to y equals, and I'm going to clear this, and I'm going to put in just the function x squared. And I'm going to graph it. So there's my function. Okay? So I'm going to go second quit. I'm going to show you how to do this on a Casio also. The calculator can show you the derivative or show you the slope of the tangent line. Okay? It will give it to you. And this is how you do it. And I will show you also on a Casio. For the TI people, you have a button on the left-hand side, 3 down. Really? It's 3? Yes. It's the most important button. It says math. If you press it and go down to line 8, there is something that says n deriv. That's giving you the numerical derivative. I press enter. Now, what I want to take the derivative is on line y1 in my graph, correct? TI people, everybody with me? So I go to vars, which is to the left of clear. Does everybody see it? That means variables. And if I push it, it gives me y variables. And that's what I want. And it's a function. And it's called y1. I press enter, and in there, I'm telling the calculator that's the derivative function I want to use. It's what's in y1. Followed by a comma, which is above the number 7. Yes?
Ours looks different than mine. We're confused over
There's like 800 blanks. The newer one has the...
Yeah, I'll show you all. You'll give me yours, and I'll show you. Okay? It's even easier. Okay? Okay? Just is yours the same as?
Yeah.
We'll see. I'll show you. Okay? Then you're going to have, now, you're taking the derivative. Your input value is x, correct? Your input value is x. On a TI, you're taking the derivative with respect to x, with respect to your input value. So you need to go up and type in your variable x, comma, and the place and the x value you want it to figure out. So let's say we wanted to know the slope of the tangent line on the function f of x equals x squared, where x is equal to 3. So we should get 6 as the answer, correct? So I'm going to type in 3 parentheses. So that's how I figure out the derivative of the function at 3. It gives me 6. Does everybody have that? Okay, that's the last time I'm going to tell you how to do the derivative, because it's in the video section. And if you simply type in, how do I compute the derivative on a Texas Instruments or a TI, there's a YouTube video of it. Everybody got it? Okay, Josh, let me see your fancy dancy one. Does anybody say fancy dancy anymore? Oh, you will have to wait till tomorrow. Come up here, you